Hello everyone. In this session of CCNA series, I will discuss OSPF area and LSA types. In OSPF, a single autonomous system can be divided into smaller group called areas. An area is a fundamental concept that plays a crucial role in the organization and scalability of OSPF networks. OSPF divides a network into areas to manage the size of the routing tables, control the propagation of routing information, and improve network efficiency. So each area is a logical grouping of routers within the OSPF domain or AS, and routers within the same area share a common view of the network topology. OSPF can be effectively implemented in small network without significant design consideration, as you can just enable OSPF in all the routers and place all the interfaces in the same area. Here I have such network with 7 routers, and all interfaces you can see are placed in area 0. But a single area architecture is inefficient for larger OSPF version 2 networks. So imagine an enterprise network with 500 routers rather than 7 and several thousand subnets. So there will be issues. So issues with large OSPF network are like, for example, the CPU time to run the SPF algorithm on all the topology data will take time increasing CPU loads on routers. As a result, the convergence will be very slow. The routers might run low on RAM as well. So a larger topology database requires more memory on each router, that is increased memory requirement. The link state database will get larger and the routing table will get larger as well, which in turn the number of LSAs flowing in the network will increase. The solution is hierarchical area design. The solution is to divide the solution is to divide the larger LSDB into smaller one using OSPF areas. So this will help in minimizing the size of the database, decreasing the routing table size, reduced link state updates, which will minimize processing and memory requirement, and reduced frequency of SPF calculations, which will localize the impact of topology change within an area. OSPF allows the network to be designed in two-layer hierarchies: backbone area and non-backbone area. The backbone area is the core of the OSPF network and all the other areas are connected to it. The backbone area is also known as area 0. It is the most important area in the OSPF network and is responsible for routing traffic between nodes from all the other areas in the network. This is because OSPF expects all the areas to inject routing information into the backbone, and in turn the backbone disseminates the routing information into other areas. So without backbone area, multi-area OSPF would not be able to function properly. The non-backbone area, all the areas that are not the backbone area are called the non-backbone area. So each non-backbone area must be directly connected to the backbone area. Let's look at some of the OSPF router types or roles. Router in OSPF can be categorized based on areas, such as area border router or ABR. An OSPF router with interfaces connected to the backbone area and to at least another area is called ABR. A backbone router, another type of router in OSPF, is a router connected to the backbone area, which can include ABRs as well. Actually, a router with at least one interface attached to the backbone area is called backbone router. Or router whose all interfaces belong to area 0 is called backbone router. Another type of router we have is internal router. A router particularly in an area, is called internal router or router whose all interfaces belong to same area. Then we have another type of router called as ASBR, also known as Autonomous System Border Router. It connects OSPF area to another AS, such as EIGRP. Next, let us look at some of the OSPF route types. In OSPF, there are two route types: intra-area route and inter-area route. Intra-area routes are routes that are originated, learned, and routed within the same area. These routes are meant for the router inside the same area. Sorry. As I said, uh, it is generated by every router to other router within the same area. These LSAs contain information about router's IP address, interfaces, mask, router ID, and status of each link. Then we have type 2 LSA, also known as network LSA. These LSAs are generated by the DRs on multi-access network. The DR uses type 2 LSAs to send out information about the state of the routers that are part of the same network segment. And these LSAs are flooded between neighbors in the same area of origin and remain within the area. These LSA contain the DR and BDR IP information. The third type of LSA we have is type 3 LSA or summary LSA. These type of LSAs are generated by ABRs to advertise the route between OSPF areas. They contain information about routes to network outside of the originating area. Advertisement contain the IP information and router ID of the ABR that is advertising this LSA. The type 4 LSA, this is the fourth LSA, also known as ASBR summary LSA. These LSA are generated by the ABRs. These LSA are generated by ABR to advertise the location of the autonomous system border router within an OSPF area. There are also summary LSA like type 3 LSA, but type 4 are specifically used to inform the rest of the OSPF areas how to get to the ASBR. Then the fifth type of LSA we have is type 5 LSA, also known as external LSA, generated by the ASBR to advertise external routes such as route redistributed from other routing protocols such as EIGRP into the OSPF domain. These are advertised by the ASBR only and also owned by the ASBR. These are LSAs used to advertise network from other autonomous system and are flooded through the entire autonomous system. That's it for this session. I hope this was informative for you. Thank you for watching.